Hi, Assalamualaikum. My name is Muhammad Uzair and I will be start to present the group 10 of microprocessor and microcontroller project. Starting off with the group members. We have Nurul Natasha, Alice binti Zahari, Natalie Tan Yi Wan, Muhammad Hidayat bin Halim, and myself Muhammad Uzair bin Tajul Ahmad. Next is the project description. Microcontroller is a compressor microcomputer manufactured to control the function of embedded system in office machine, robot, home appliance, motor vehicle, and several other gadgets. A microcontroller is comprising components like memory, peripherals, and most importantly, a processor. This project is a design of a multifunction microcontroller with PIC 16F877A as the microcontroller. The program is designed to control the main program, which is keypad operation that will display two random digit number depending on which key that been pressed. Another operation is the interrupt service routine or ISP program that will control the LED with a push button. That's all from me. Thank you.
Okay, so next is program flowchart. We'll go straight to the delay routine. So at delay, we are setting the timer as 255 hexadecimal, and we will keep decreasing the timer by 1, and it will keep continue until it is equal to 0, and then after the timer is equal to 0, the program will return to the previous program line. Okay, so next we move to the main program. So first we initialize port B, port A, port C, and port D as input and output. And then we set port A, port C, and D as 0, and then set counter equals to 3, and then print 1 at port C, 0 at port D, and turn on all LEDs, and and enables the interrupt. After that, we move to the column 1. So at column 1, we initialize port B equals to 0, and then we check if RB2 equals to 1, we set the register as 1, and then we check if status Z is equals to 1, we'll move to the BB, we will print 2 at port C and have a delay, and print 1 at port D and have a delay. And then we will continue, we will repeat the column 1 until status Z is not equals to 1. Next, if status Z is not equals to 1, we will check if RB3 is equals to 1. So if RB3 is equal to 1, we set the register at S1. So after that, we check if status Z is equals to 1. So if status Z is equals to 1, we print 4 at port C and have a delay, and then print 5 at port D and have a delay routine, and print A at port C and have a delay routine, and we'll continue at the row at the next page. So if status Z is not equals to 1, we will go to the column 2. So next, we will continue the previous process. So we print F at port D, and then have a delay routine, and print 3 at port C and have a delay routine, print E at port D and have a delay routine, and go to the column 2. So at column 2, we initialize port B equals to 1, and we check if RB2 is equals to 0 or not. If RB2 equals to 0, we set the register as 1, and then we check if status Z is equals to 1. So if status Z is equals to 1, we print 9 at port C and have a delay routine, and print 9 at port D and have a delay routine, print B at port C and have a delay routine, and print 1 at port D and have a delay routine. And then we will move back to the column 2 until status Z is not equals to 1. So if status Z is not if status Z is 0, we will move to RB3. We will move and check if RB3 is equals to 0. So if RB3 is equals to 0, we set the register as 1, and we check if status Z is equals to 1, we print 4 at port C and have a delay routine, and print F at port D, and we'll continue next. But if status Z is not equals to 1, we will repeat the program at column 1. So next. So let's continue. Okay, so from previous program, we continue with the delay and then print 9 at port C and have a delay, and print 8 at port D and have a delay, print 4 at port C and have a delay routine, and print 4 at port D, have a delay routine, print 6 at port C, have a delay, print 7 at port D and have a delay, and then we will return to the column 1. Interrupt service routine. So firstly, we will disable all interrupts, and then we check if RB7 is equal to 0. So if RB7 is equal to 0, we turn off LED at D1 and D3, and then have a delay routine, and then turn on all LEDs, and then have a delay routine, and then decrease the counter by 1 until it is equal to 0. As long as it is not equal to 0, it will continue turning off the LED D1 and D3, and it will keep looping until the counter is equal to 0. So when the counter is equal to 0, we will reset the counter to 3, and then we will return from the interrupt. So what if RB7 is not 0? So if RB7 is not 0, we will move to the custom 1. So at custom 1, we check if RB6 is equal to 0. So if RB6 is equal to 0, we turn off LED at D0 and D2, and then have a delay routine, and then turn back all LEDs and have a delay routine, and then reset the count. And then decrease the counter by 1 until the counter is equal to 0. As long as it is not equal to 0, it will continue doing the looping at turning off the LED at D0 and D2 until the counter equals to 1 and equals to 0. And then after the counter equals to 0, we will reset the counter to 3 back, and then we return from the interrupt service. Continue. Okay, so next, if RB6 is not equal to 0, we'll move to the custom 2. So at custom 2, we check if RB5 is equal to 0. So if RB5 is equal to 0, we will turn off LED at D1 and D2 and have a delay routine, and turn on back all LEDs and have a delay routine, and then decrease the counter by 1 until the counter equals to 0. So it will continue as long as it is not equal to 0. And then if the counter equals to 0, we will reset the counter into 3 back just like before, and then return from the interrupt service. So what if RB5 is not equal to 0? So if RB5 is not equal to 0, we will move to the next program, which is custom 3. So at custom 3, we'll check if RB4 is equal to 0. So if RB4 is equal to 0, we turn off LED at D0 and D3 and have a delay routine, and then turn on back all LEDs and have the delay routine, and then decrease the counter by 1 until the counter equals to 0. So if the counter is not equal to 0, we will keep decreasing. We will continue, or we will go back to turn off the LED at D0 and D3 until, and then continue the program until the counter equals to 1. And then, until the counter equals to 0. So if counter equals to 0, we will reset the counter into 3, and then we return from the interrupt service and coming back to the program before. So if RB4 is not equal to 0, we will also return to the interrupt service. So we return from the interrupt service. So that's all for the flowchart. Thank you.
My name is Natalie, so now I'm going to present on the stimulation demo. Okay, we already insert our hex file into the PIC, and then now we run the circuit, so we can see from here that the LED shows 10, which represent our group number 10, and all the LED is turned on. So before we start our demonstration, I would like to mention that we already declare the interrupt instruction in the program code, which is RBIE The RBIE means that we enable the interrupt caused by RB4 to RB7, and also the RBIF. If RBIF equals to 1, means that the interrupt happened and it will go to ISR setting. And last one is the port setup and condition. Okay, so we do set the tree speed to 11111100, so which means that from RB2 to RB7 is in the state of 1, and RB0 and RB1 is in the state of 0. Okay, so now we would like to go to our main program. So first we look at column 1. You can see from here, column 1 we have button 1 and button 4. Also the PIC here, we can see that we connect column 1 to RB0. So the first thing is we set RB0 to high to scan row 1 and row 2. Okay, now we're going to row 1 column 1, which is the button 1. So here we can see that row 1 column 1, row 1 is connected to RB2. So now if the button 1 is pressed, so RB2 equals to 0, and then it will skip the next instruction. After that, it will check the status tag. The status tag actually is the 0 flag. So since now RB2 is equals to 0, therefore the status flag is equals to 1. It will skip the next instruction and go to the D underscore row 1 column 1. So this instruction will be checking whether the button is released or not. Okay, so the moment when the button is released, RB2 will go back to 1, which means RB2 will equals to 1, and therefore status tag will equal to 0, and it will skip the next instruction and go to display 1. So now we check the button we press and then we release, it will show 2 and 1 in port C and port D respectively with some delay. Okay, so for row 2 column 1 is the same concept as just now, but we can see from here row 2 column 1 is the button number 4, and we can see from the PIC for row 2 we are connected to RB3. So now we are checking for the port RB3 instead of port RB2. So here we will check if the button is pressed, then RB3 is equal to 0, therefore status tag equals to 1. We will skip and then we go to row 2 column 1 and check if the button is released or not. If the press button is released, then RB3 will go back to equals to 1, and therefore the 0 flag will equals to 0, and therefore it will skip this one and go to display 3. So the button 4 when we press, we can see 3 sets of consecutive number in port C and port B. Okay, so finish for column 1. Now we're going to the column 2. Okay, so we can see from the PIC here, column 2 is connected to RB1, and also column 2 we have 2 buttons, which is button 2 and button 5. So we will first set RB1 to high and scan the row for row 1 and row 2. Okay, first we will look at row 1 column 2. Actually they are in the same concept, so they will check for the port RB2 because button 2 is at row 1 is at RB2. So therefore if button is pressed, RB2 is equals to 0, status tag is equals to 1, and therefore it will skip and go to D row 1 column 1 and check for the button press is released or not. So once the button is released, it will skip, go to D row 1 column 1 and display 2, and it will show 2 sets of digits in the LED display at port C and port D. Okay, so after done explaining on the main program, now we would like to go to the ISR setting, which is the interrupt. So as I mentioned earlier, for port RB4 to RB7, it is the interrupt port. If one of the button is pressed, it will go to the ISR setup. So for example, if you press the button on RB6, it will first clear the file in RBIF, and it will skip the instruction from port RB7 because now RB7 is in a state of 1 equals to 1, so therefore it will skip go to, and it will check for RB6. So if let's say RB6 is pressed, it will go to custom 1. So let's see for custom 1. Custom 1, we move the binary of 1010 to port A. So we need to see in the reverse way. So here is 0101. So the moment when we press, we can see the first and the third LED will be turned off. So we can see it blink for 3 times because here we do set up the counter for 3 times. So it will blink for 3 times. After that, it will reset the counter to 3 again and then stop and then wait for the next instruction. So same as the other RB. If let's say we press for button and R3, then it will skip for RB7, 6, 5, and it will go to RB4 because here they are connected to RB4. So when the button is pressed, RB4 is equals to 0, so it will go to custom 3. Then we can check now custom 3 is 0110. So which means here later the first and the last LED will be turned off. And then it will blink for 3 times. After 3 times, it will reset the counter and then wait for the next instruction. Okay, so for RB7, if we press the button at RB7, here we can see the code is 0101. So we see in the reverse way, here is 1010. So we can see later the second and the last LED will be turned off and blink for 3 times. And then for the case same as port RB5, so we can see from here RB5 is, we will go to custom tool, and then it shows 1001, so which means the center of the 2 LED will be turned off when you press the button. So we can see that when we are playing around to the interrupt program, there will be no changes in the port C and port D. And also same as when we are playing around with the button at port B to port C, we will just see the changing of number, but the LED are still on because there's no interrupt happen.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hidayat Alim. I'm from Group 10. As for the conclusion, based on this lab, we have required to understand and complete the experiment objective by studying the microcontroller system that can control any embedded configuration applied. The main aim of this lab is to be able to design and understand the working principle for the microcontroller system. There are several hardships occur in this lab. First of all, when we are identifying the address, and there will be some issues during the process for the microcontroller system. Developing and understanding the programs of this lab also give ideas and lessons on how to code the system successfully. The first program that we do is for the keep operation that need to develop a program that can display the number that has been coded into the segment display according to the case study. Next is for the interrupt service routine (ISR). The ISR examines and interrupt and determines how to handle it, execute the handling, and then returns a logical interrupt value to perform for the basis route. Lastly, communication with the team members also plays a vital role in designing and developing the project successfully. Thank you.